Hello there, it's Alana, and I'm here to help you with 4.2 number 24 from my Math Lab study plan. And again, as usual, I don't know where it's going to show up in your homework or homework sets. This one has a T after it. That means this is a technology problem, so we're going to be definitely using Excel or Statcrunch to do this. Probably Statcrunch, to be honest, because it's faster. Okay, so, or maybe I'll use both, who knows. All right, so I'm going to click on the example because that's the problem I'm going to do. Then I click on the icon to copy the data and go here to copy the date to the clipboard. And I was being bad. I really should have read this, but I've already read it a couple times. So the accompanying data represent the number of days absent X and the final grade Y for a sample of college students in a general education course at a large state university. So our first mission is to find the least squares regression line treating the number of absences as the explanatory variable, which is kind of obvious because it's X, and the final grade is the response variable. Again, obvious, that's Y. Okay, so let me paste it in. Now we can do this a couple ways. You can do it with Excel. Excel has formulas for, now remember, it's y equals mx plus b, or ax plus b if we're in stats class. That's the general form for the equation of a line, right? Y hat, technically, but I can't make that easily. All right, so what we need is we need a and we need b. Okay, so a is the slope. So you say slope, there's your function. You say your known, now this is weird, it goes backwards. It wants your y's first and then your x's. So your known y's are those, is that array. So b2 comma b11, your known x's right over here. Done. And then you want your intercept, and that's the intercept command, the intercept function. So you say intercept, and again it goes backwards. There's a good reason for that, which is it's basically that there's actually multiple x's possible. That's something you learn in chapter 14 if you take like a Stats 2 course or something. Basically, Stats 2 spends a lot of time in regression that we're not doing. There we go. So we've got these two. Life is grand. And how many data points did they want? I think they want like 3 decimal places. So if you want 3 decimals, you can just highlight the cells and right click, format cell. Wait a minute. There it is. Number 3 decimals. Cool. Okay, we're done with that part. Let's see what else they want to know. So I'm going to continue here. Oh, interpret the y, the slope and the y-intercept if appropriate. Fine, wonderful, marvelous. We'll fast forward through all of that. And I'll just do it in Excel with you. Now they'll have some kind of multiple choice question for it probably, but we're going to kind of explain it. So remember what this was. This is saying X and Y here. So we would say, I'll put it up here, interpretation. And both of these have valid interpretations, by the way. So I think the easier one to see is actually the intercept. This is the intercept. Let me label these. And the top one is the slope, just so you can keep them straight. Slope is whichever one's multiplied by the x. So that's your slope. Okay, so now how do you interpret this? Let me start with the intercept because it's easier. Remember, the intercept is what happens when x is 0, right? Roughly. Now, it's not what really happened. What really happened was 90.4, but what you're looking at is a model. Here, let me make you guys a scatter plot real quick. Okay, if I add the trend line, linear trend line, hey, I'll display the equation just for the heck of it. That's another way actually to find, see, there it is. Same equation. So the line hits at 89.9. The dot is at 90.4. Now they're very close together, so it looks like they're on top of each other, but they're not, right? That's the difference. We don't need that. Okay? All right, so let me move that out of the way. And by the way, catch, that's another way. If you right-click Add Trend Line, you can find the equation that way as well. So there you go. And I found the r squared that way as well. Okay, so to interpret this, let me shimmy this guy out of the way. It's saying that when x is 0, but x was the absences. So how about this? A student who has 0 absences can expect a grade of about 89.9 in the class. There we go. Because that's the intercept. It's over here when x is 0. It's where that line hits the axis. All right, now the slope. Well, the slope is this, well, look at that black line. it's literally the slope. It's how fast you would fall down that line if it was a slide, right? So if that's a slide and you're rolling down it, it's how fast you go down it, right? Steeper slopes mean you fall faster, right? So it's a ratio. It's saying, and a lot of you learn it in school as rise over run. It's horizontal to vertical, right? How much, oh, excuse me, rise. So vertical over horizontal. Sorry, I misspoke. So it's saying, from up here, you drop down, go over, there's a ratio there, and you can explain it. So the run for us is always 1. So we always say for every 1 x, and x for us is absence. Okay, so for every 1 absence, a student can expect their grade to drop, go down, whatever, decrease by 2.7945. Done. Okay, or 2.795 if you like. Right? So rise, remember, rise over run. So it's negative 2.795 over 1, right? Everything's over 1. Oops, it doesn't like that. Let me put it in quotes. I don't really need it to be equals. I just need it to do it. Okay? So if that's the case, you're saying drop 2.795. Right? Oh, quit doing that. Hold on. There we go. I got it to stop fighting me. So you drop 2.795, meaning your grade goes down, your y goes down 2.795 every time your x goes up by 1, and you got to explain what x and y are in the context of the situation. All right, so pick whichever, multiple choice one matches that. Then they want us to predict the final grade for a student who misses 5 classes. Okay, let me shimmy this over here. Okay, so remember it's y equals ax plus b, and they're telling you x is 5, and they're asking you what's y, question mark. Okay, so you'd say, okay, that's ax plus b, so 2.795 times 5 plus 89.905. And there you go, 79.932. And again, I don't know how many decimal places they want, but let's give them a couple and see what happens. So continue. Let's see what they're looking for. Oop, there it is, 75.93, right there. Done. Okay, so then they want the residual, I bet. So if they want the residual, then we'll have to find that. That's the difference between what we just got and what we expected to have happen. So let's see, residual. Residual is, and let me give you the formula for it. Residual is equal to observed minus predicted. Okay, so that would be equal to what we observed in real life for 5 absences, which was 75.1, take away what we predicted would happen from the line, which is 75.93, and there it is. Right? And you can, it's hard to see because it looks like the blue dot is right there on top of it, but it's not. Let me change my scale. Hold on. So if I go here and right click on those numbers, let me format this axis just a second. So if I'm going to make it go as low as 60, there we go, 60 to fix it at, I don't know, 91. Just for the heck of it. Okay, so now you can see a little bit better. See how that blue dot is not really on the line? See that? What you just found is the distance between the two. You found the distance between the blue dot, the center of that blue dot really, and that line. That distance is negative 0.83. It's negative because the dot, the real life dot, is below what the line actually was, which means we underestimated because residual is negative. Or if you like, you can think it was the student scored a little high. The student overperformed, right? Because they scored a little bit higher than students dot. Oh no, student underperformed. I'm sorry. I'm doing this spell backwards. Overestimated. Oh, I'm losing my mind. Sorry, it's an overestimated because The estimate is the line itself. Sorry, I was losing track. The estimate's the line that's over the dot. So we overestimated because the residual is negative, right? Line is over the dot. Let's think of it that way. Because the line is above the dot, right? Or you can think of the student as underperformed student, right? Again, because residual negative, i.e. the line is below the dot or above the dot. Sorry. Since the dot is below the line, the student is performing lower than they should have. Or conversely, the line is overestimating what the student should have. Okay, so that's how to find the residual, which they asked for, and that's how to find the prediction they asked for. Let's see, what else do they need? Draw the least squares regression line. Oh, I already did that, right? So I don't know if you caught how I did it, but I'll just do it again. You highlight the data, insert, scatter plot, boom. You can delete this legend over here, you don't need that. Then you right click, click and then right click and choose add trend line. You want a linear regression line, and I personally like displaying the equation in R squared just because I like having them somewhere. Close. Then you can drag them, this little box, wherever you want. It's basically a text box. So, and if you want to fiddle around with titles and such like that, like you would have to for a project, that's a different story. So this is absences. And then over here was final grade. Oops. I didn't mean it that way. I always like the rotated one. And so this is student absences versus final grade. There we go. Boom. All right, let's make sure that there's nothing else that we need to cover. So we've shown the graph. There it is. It matches ours. Beautiful, marvelous. Would it be reasonable to use the least squares regression to predict for 15? Well, that's getting a little bit of ahead of yourself. So the thing is, you don't want to go too far in the future. Like, I'd be comfortable with 10. I mean, 10 is really close to our data. But going all the way up to 15, that's a lot. Like, our data only goes 0 to 10. So being absent 15 classes in a class that usually only meets 30 times, it's like half the classes. So that can get a little crazy. All right, so one other real quick thing. I wanted to show you how to do this in Statcrunch. So let me pull that up. One sec. Okay, so here's Statcrunch. I'm going to copy and paste the data in. Oh, it's a little small. Hold on. There we go. All right, so then you go to, let's remind myself, stat, I think. Yep, stat, regression, and you don't have to highlight the data. I'm just fiddling around. So stat, regression, simple linear. All this other stuff is stuff we would do in later chapters, but we're not doing it. Simple linear, your X column is absences, your Y column is final grade. We have no group by or anything. Next. You can ignore this. This is, again, more of that chapter 14 stuff that we don't get to in this class. Residuals isn't a bad idea if you want. That'll cut out some, and we can do this right here. We said we wanted to know what it was when X was 5, so I'll put that in right there. And of course, you'd have to look at your problem and know what it is for yours. So, and I'm going to save the residual, and then it'll automatically calculate that residual. I'm going to plot that fitted line because they asked us to. And I think that's it. So let's calculate. Okay, so there's the equation right up here. See it right there? It's the same numbers, but it writes it differently. It writes the intercept in front. So it's like instead of ax plus b, it writes b plus ax right there. Okay, so, but it's still there. That's the equation. And you can see them right here as well. There's the intercept. There's b, and there's a, the slope. Okay, and in case you're interested, there's the correlation coefficient and stuff. Next, there's your lovely fitted line. Isn't that beautiful? Oh, there should be a prediction value. Oh, it's right down here. See that? 75.93, just like we found 75.93. And then it also found, residual stored in the new column. So let me go back to Statcrunch, residuals. And there it is, negative 0.83. That's that residual we found. See right there? Cool. So that's how to get Statcrunch to do it. Statcrunch does it all in one as long as you get every little button and check. One thing is if you don't get it all, you can always go back and up here to options, click edit, and you can go back and like say you didn't know it was 5, you can go back and put 5 in right now and then still do it. Okay? I'm all out of time, so I hope that helped.